Hello, welcome back. In this video, we'll be discussing the introduction to inequalities. An inequality is any statement that holds between two values when they are different. Here we have 5 is greater than -3. So this right here is called the inequality sign. And the symbol, you'll see there's like a little open section here, always opens towards the bigger value. So we're saying 5 is greater than -3. Or on this next one here, I can have 4 is less than 12, as long as it's true. 4 and 12 are different. That statement holds true. Notice it's opening towards the larger expression. Or I can add this line under them, and those are equal to. So this one would be read as 5 is greater than or equal to -3, which means I could also write -3 is greater than or equal to -3, and this statement would still be true. And the same thing with the bottom, 4 is less than or equal to 12. Graphing. So here we've gone ahead and put a variable in there. And notice that the inequality is opening towards the n, the variable n. What that means is all values of n are greater than -3. So what we do is we find -3 on the graph. And we're going to go ahead and put an open circle there, and that's our starting point. So if we put that -3 in place of n, -3 is greater than -3, we can see that that is actually false. That's false. If your answer for that is false, you start with an open circle. But we want to pick numbers that are greater than -3, so we're going to pick another number. Let's say we pick the number 1 and put the number 1 in there. 1 is greater than -3. That is true, which means anything on the right-hand side of -3 is going to give me an answer that makes this inequality statement true. But if I were to pick something on this side, let's say I pick the -6, and I put -6 is greater than -3, well, that would be a false statement. So all the solutions are actually found to this side of -3, and this right here ends up being our graph. We'll graph this one. 7 is greater than A, or you could just say that A is less than 7. And again, we're going to find 7, which is over here, and it's not equal to, so we're going to put an open circle, because if I put a 7 in there in place of A, 7 is greater than 7, that would be false. So we're not part of the solution. We're not going to color our dot or our circle in, and we've got the rules for that at the end. So let's go ahead and figure out where are the answers going to be located, to the right of 7 or to the left of 7. One easy thing to pick would be a 0. As long as your dot's not over 0, you can put the 0 in place of A. Remember, these are all our values for A, so I can put a 0 in place of A and fill this statement out and ask, is that true? 7 is greater than 0. That is true. So since 0 is a solution, I want to arrow towards that solution, and everything to the left of 7 on the number line represents all the possible solutions for A. So in an inequality, one of the biggest differences you'll notice is instead of one solution, you'll have infinite amount of solutions. We'll try another one that has an equal to sign under it. Okay, so I'm looking for A's that are greater than or equal to 1, or I could say 1 is less than or equal to A. So what we're going to do is find number 1, which is here. And you'll notice it has the equal sign underneath it, which means instead of an open circle, we're going to go ahead and fill that in, and you'll see why. If I take this number 1 and place it in for A, and then I rewrite the equation, we say that 1 is less than or equal to 1. Well, that is true. The dot here is not just a boundary line as to where we start our graph, but it's also part of the solution, whereas the ones that were open circles were not part of the solution. Now I got to pick a number. 0 is always a good one to try, and substitute it in place of A. So in place of A, I'm going to put a 0 is greater than or equal to 1, and ask yourself, is that true or false? 0 is greater than or equal to 1. That is actually false. So I don't want to arrow towards 0. I want to arrow away from 0. But another little shortcut here, or a little hint, you'll notice that the inequality is opening towards the variable, and my arrow again is going to the right. So at the end, we've got a little shortcut note you might want to go ahead and take down. Graphing inequality again, m is less than or equal to 5. So we're going to go ahead and find the 5, which is over here. So I'm going to put a solid dot, again I'm putting a solid dot because of the equal to sign. If I pick 0, which is here, put 0 in place of m, 0 is less than or equal to 5. Well, yes, it is less than 5, so that makes it true, so I'm going to arrow towards that solution. Or, notice again that the inequality is facing away from the variable, which means I'm going to arrow to the left or find all my solutions to the left of my boundary line or my starting dot. So a couple of rules for you. Arrow to the right when the inequality sign opens towards the variable. So it opens towards, then you're going to arrow to the right. You're going to arrow left when the inequality sign opens away from the variable. We're away from the variable. Use an open circle. You're going to use an open circle when you have either this symbol or this symbol. That means the dot itself or the open circle is not part of the solution. It makes it false. And if you see the equal to signs with your inequalities, then you're going to use a closed circle. And what that means is that is your starting point, but is also part of the solution.